Hello again, grade 10. This is our fourth online lecture. As I told you before, we are going now to continue our first chapter, which is sets. If you remembered, last week we explained the first two objectives of the lesson, and now I'm going to continue the others. So let us just make a quick revision. So in the previous video, we did the first two objectives, which is determining the rules of writing sets and utilize basic symbols, and to define the notion of subset of a set. In this lecture, today, we are going to introduce the elementary operations on sets, and we are going to recognize important sets are sets of numbers that are natural numbers, integers, rationals, irrationals, and real numbers. Before I start with the new objectives, I'm going to make a quick revision for the previous objectives so you can continue with me. So first, let us remember together what's the meaning of a set and what's the meaning of an element. So any collection of objects is a set, and the objects inside the set are called the elements. We have two methods in order to write a set. The extension method, which defines a set by listing its elements, and they are separated by commas within curly brackets. So as an example, we have the set ABC 1, 2, 3, 4. As you can see, it's in the extension method where we listed the elements and they are separated by commas within curly brackets. And we also have another method, which is the set builder notation or the comprehension method. It gives a description of how the set is built rather than listing them. So I don't list the element, I just describe what's the element. As an example, we have C, a set C, usually a set it's written in a capital letter, equal, and the curly brackets. They are telling us that set C, it contains an element, and those elements are vowel letters. So you can write it in extension method, and it's A, E, O, U, I, and Y. But the set builder notation or the comprehension method is C, X, such that X is a vowel letter. Now let us continue. We have the cardinality of a set, and we said that the cardinality of a set is the number of elements in that set, and we usually represent it, for example, n of p, n of a, n of x, and you count the number of elements and you put it. Equal sets are sets that contain exactly the same elements. So if you have two sets are said to be equal if they have exactly the same elements. Empty sets, as we learned before, are sets that do not contain any element at all, or the elements inside this set is only phi, which represents the empty set. And some sets are, for example, the pair set. It contains only two elements. The singleton that contains only one element. Now let us continue. And now we have a subset, and we said that a subset is a set. So first of all, a subset is a set whose elements are all members of another set. This set, it's called the universal set, which is larger, and it contains at least all the elements of the other sets in the discussion. Okay? So if we take an example, we have set U, which is the universal set. It contains A, B, C, D, E, and F. T, which contains A, C, F, and A that contains A, B, D, they are subsets of U. Why? Because the elements of set T and the elements of set A belongs to U. Now, if I want to list the elements that are in U but aren't in T, that means I'm trying to find the complement of T, and we represent it as T bar. So when I say T bar, A bar, it means the elements that are in U but they are not found in the indicated set. So we call it the complement. And now I'm going to start by our new objective. So starting from now on, I'm going to explain something new. So let us first define something called intersection and union. They are very easy terms. From the word intersection, you can think for a minute, and you can, for example, suppose you have two sets. What's the meaning of the intersection of two sets? As if I'm trying to find what are the elements that are found in those two sets. So the element that you can find it in two sets, in two different sets, this element, we call it the intersection of the two sets. Okay? And what about the union? The union is, I need all the elements that are found in the first set or in the second set. So please, the word intersection, its term is and. The term union, its term is all. Keep this in mind and let us continue. The intersection of two sets A and B is the set containing the elements of A and the elements of B. So it should be, the element should be in A and in B at the same time. Let us see. That's how we represent the intersection. A intersection B. If you see the symbol here, this symbol indicates that I'm finding the intersection. So intersection is symbolized like this, and the union is symbolized like this. So let us now work on intersection. Suppose we have set A, which is 3, 4, 6, 8, and the set B, which is 1, 2, 3, 5, and 6. Now we can say that A intersection B are 3 and 6. So the elements that are found in A and in B. So please pay attention for the word and. It should be found in both. It's 3 and 6. So when I say intersection of two elements, of two sets, I mean the elements that are found in the first set and in the second set at the same time. Now, union. The union of two sets is the set containing those elements that are found in A or in B. What does that mean? We have the set A, 3, 4, 6, 8, and the set B, 1, 2, 3, 5, 6. So A union B is 1, 2, 3, 4, 5, 6, 8. Don't forget that you don't repeat the number twice. So if it's found in A or in B, you just write it once. And I need all the elements. Okay, as if I'm trying to find the universal set. As if I'm trying to find the universal set that contains all the elements that I found in the other two sets. So what did we learn till now? Something new. We learned two terms, the intersection and the union. When I say intersection, the elements should be found in A and in B. When I say union, the elements should be found in A or in B. One of the important diagrams that represent a set is called the Venn diagram. In the Venn diagram, as you can see, we have two circles. I think you used to take this in English. You use the Venn diagram for representing the similarities and differences. Okay, the similarities and differences, it could be, for example, in math called the union and the intersection. So this Venn diagram represents two sets A and B, but the blue part represents the elements that are found in A. In the second diagram, you can see that we also have two sets A and B, but the blue parts in this case represent the elements that are in set B. In the third diagram, you can see that we represent the intersection between the two sets, which is A intersection B. And in the last diagram, we can see that it's the union of the two elements. And now, algebraic properties about the union and the intersection. You have to know that union and intersection are commutative operations, which means A union B is the same as B union A. A intersection B, it's the same as B intersection A. You have to know also that the union and intersection are associative operations, which means A union B union C, it's the same as A union B union C. So it's associative. Also the intersection, A intersection B intersection C, it's the same as B intersection A intersection C. Also you have two distributive laws that are true. A intersection B union C, it's the same as if you are distributing the A intersection B, then union A intersection C. The same thing for union. So A union B intersection A union C. It's the same thing. And you have to know that A union phi is of course A. A union A, it's A. A intersection phi, it's of course phi. And A intersection A, it's also A. Now we are going to take the important sets in math, which are set of numbers. So I'm going to start first by natural numbers, or we represent it as capital N. Natural numbers are only the positive numbers. They are numbers and not decimals that contain decimal parts or radicals or fractions. It's not. Natural numbers are integers, but they are only positive numbers. N star, it's all the natural numbers but without 0. The second set is the integer numbers, and it's all the negative and positive integers numbers, and we represent it by Z. So every time you see Z, I mean the negative and positive numbers, but N, it's only the positive numbers. And also Z star is N. It's the same as N because I'm only listing the positive numbers. Z star is the set Z, but without a 0. The third set is the rational number, or the unlimited or the repeated decimal. So for example, if you have a decimal number that never ends, for example the pi, you know that pi, which is 3.14, 15 and so on, it doesn't end. So pi is a rational number because the decimal part in it never ends. It's unlimited. So we can say that the rational number such that a over b, where it's a fraction of course, but it never ends. For example, we have 2 over 3, 2.33333, and so on, 1 over 6. So all of these are rational numbers. And real numbers, it's the rational plus irrational. So real numbers, actually it contains all the numbers that are between minus infinity and plus infinity. So for example, radical 2, radical 3, radical 5, pi, radical pi, 2, 3, 1 over 2, 1 over 5, all of these are real numbers. If you look at the following set of numbers, you can see that some of them are subsets of each other. You have to know that the universal set is the real numbers because it contains all the numbers between minus infinity and plus infinity. Natural numbers are only the positive numbers. So it's a subset of wholes, and it's a subset of integers because integers, they contain the negative and the positive numbers. So natural numbers are subsets of integers, and integers, they are subsets of rationals, and all of them, they are subsets of real numbers. So now I'm done with our chapter. What we have learned is two new terms, the union and the intersection, the union of sets and the intersection of sets. We have learned the Venn diagram, and we introduced a new set of numbers and their elements. And now I'm going to make exercises, I think 2 exercises, and we will be done. So let us start by the first exercise. In the first exercise, we have this Venn diagram that contains 3 sets inside the universal set, which is E. So we have the universal set, which is E, and we have sets G, F, and H, 3 sets that are subsets of E. The first question is, write in roster notation the sets E, F, G, H, G bar intersection F, and so on. Let us first start to write the set E. What's set E? Set E is A, B, C, D, E, F, G, H, I, J, K, L, M. So this is the set E, which is the universal set. Now what's set F? F, if you look at the circle, this is F. Okay, this is circle F. What are the elements in F? The elements in F are A, B, C, F, G. So the elements are A, B, C, F, G. Now in G, if you look at G, this is the set G. What are the elements inside G? Are C, D, E, F. So the elements in G are C, D, E, F. Now we still have H, and the elements in H, as you can see, we circle like this, and the elements are G, F, H, I. So this is H, E, F, G, H, I. Great. Now I want G bar intersection F. So first of all, I need to find G bar. Quick reminder, G bar are the elements that are found in E but not in G. So G contains C, D, E, F. So G bar contains A, B, G, H, I, J, K, L, M. So the sets that are found in E but not in G. So this is G bar, A, B, G, H, I, J, K, L, M. Now I need to find the elements that are found in G bar and F. So I need the intersection of G bar and F. If you look at F and G bar, the common elements are A, B, and what else? G. So those are the common elements A, B, G. Okay? The same thing I'm going to continue. I need F union G bar intersection H. No matter how long it is, you just divide your work. You divide your work. So I will start first by F union G. So first of all, I'm going to find F union G, which is the elements that I found in F or in G, both of them together. So if you have any repeated number, you just write it once. So the elements that are found in F or in G are A, B, C, D, E, F, G. Now what's F union G bar, or in another word, the elements that are in E but not in F union G? It's H, I, J, K, L, M. Now I need this set intersection with H. So the only elements that are found in H and in F union G bar at the same time are H and I. I wish you are understanding every step. So as I told you, just divide or partition. It's a partition of work. So now I have F bar intersection G intersection H. So the first thing I'm going to do is to find G intersection H or F bar. Both of them will lead you to the same answer. So I'm going to now find F bar. So F bar are the elements that are found in E but not in F. So they are D, E, H, I, J, K, L, M. Now after finding F bar, I need to find G intersection H. So G intersection H is E and F. So the elements that are found in G and in H at the same time are E and F only. Now I need the intersection of those two sets. The intersection is only E. So the only intersection between them is E. We still have one, which is G union F union H. So the first thing I'm going to do is to find G union F union H, then find its bar or its complement. So G union F union H are the elements that are found in G and F and H. And if you have any number which is repeated, which is common, you just write it once. So this is G union F union H, and now its complement is J, K, L, M. I advise you to redo this exercise before you go to the worksheet and then check your answers, okay? Because this exercise is very important. And in this exercise, we have the set E that contains -2, -1.3, 1 over 3, 1 plus radical 2, pi, and 3.44444, and so on. Write in extension each of the subsets. X belongs to E and X is irrational. So from E, what are the irrational numbers? The irrational numbers are 1 plus radical 2 and pi. Go back and revise what's the meaning of irrational. Irrational are numbers that never end. Okay, so it's 1 plus radical 2 and pi. In part B, they also belongs to E and it's rational. Rational are numbers that you can write them as fractions. So the numbers that you can write them as fractions are -2 because -2 it's -2 over 1. The same for -1.3, it's -1.3 over 1. 1 over 3, it's already a fraction. 3.4444, should I remind you that it's 34 over 9? So, each one of this set, which is set B, could be written as a fraction. So we call it a rational number. In part C, we have X is an integer. Integer could be negative or positive, whole number. So it's only -2. This is a singleton set because we have only one element. Now we need to find the following subsets, A intersection B. So what are the elements that are found in A and in B at the same time? It's 5 because we don't have any common elements. Now what are the elements that are found in A and in C at the same time? It's also, it's A union C. So I need all the elements that are found in A and in C. So they are -2, 1 plus radical 2, and pi. Now I need A intersection B union C. So it's also 5 because B union C and intersection with A, it's nothing. We don't have any element which is found in A and with B union C. So that's everything about our lesson. So now at the end of this chapter, you will be able to use different diagrams to represent sets. One of them is the Venn diagram. You are going to recognize sets of numbers that are natural, integers, rational, irrational, and real numbers. So that's everything, guys, about the sets. I advise you now to watch the video one more time, take notes, then go and solve the worksheet, and meet you hopefully in our Zoom live session.